Hello friends, welcome to this session of Is Matter Around Us Pure? This is our third theory session for the topic. In this session, we are going to discuss about the impure substances. We have already discussed about pure substances, about the elements and the compounds. Now we'll be discussing about the impure substances. The impure substances are called as what? The mixtures. Impure substances are the substances which can be separated into the other forms of matter by physical methods of separation, or the components or constituents present in the impure substances can be separated by the physical methods of separation like evaporation, like distillation, like filtration. So we'll be discussing about these impure substances, about mixtures in this session. So let's start our session here. Impure substances or mixture. A mixture is a combination of two or more substances, that is the elements or compounds, which do not combine chemically with each other and may be present in any proportion. So an impure substance is a mixture, and in them the elements and the compounds are present which do not combine with each other chemically. So in the compounds, say I am taking example of hydrochloric acid. In this, the hydrogen and chlorine, they react and they form the compound, that is HCl, that is hydrochloric acid. But in case of mixtures, there is no chemical combination of such sort. For example, salt solution. In this, there are two pure substances, salt, that is NaCl, and water. They are mixed, and what are you getting here is salt water. Now we can easily separate salt from salt water by evaporation. Likewise, sugar solution, that is also a mixture. That is a mixture of sugar and solution, sugar and water. Sugar and water do not combine chemically. Air is a mixture of different gases, right? The gases from the air can be separated, say nitrogen from air or oxygen from air can be separated by fractional distillation. It is a method fractional distillation, right? It is a method for separating the different gases whose temperatures are different at which they melt. Right, at which they change into their liquid states. Milk is also a mixture. Now, what are the properties of mixture? A mixture may be homogeneous or heterogeneous. We'll be discussing this homogeneous or heterogeneous later. A mixture can be separated into other kinds of matter by physical process. Say the gases present in the air can be separated by fractional distillation. Salt can be separated from salt water by evaporation, right? So there are many other examples where the components or constituents of the mixture can be separated by physical processes. Say steel I am taking as. Steel is an alloy of iron. Some percentage of carbon is also there, say 0.2% carbon. Some nickel or chromium is also added to it. Now this is a mixture. Iron is not reacting with nickel. Iron is not reacting with chromium. Neither it is reacting with carbon. Now they can be separated when the steel is melted. Right? A mixture does not have fixed composition or fixed melting point and boiling point. Say a compound. A compound has a fixed melting and boiling point. Water has a fixed boiling point, and that is 100 degrees centigrade. Right? Likewise, other compounds have also got fixed melting and boiling points. But a mixture, the sugar solution, it will not have a fixed melting and boiling point. Its boiling point will vary depending on the amount of sugar present in the solution. That is, the boiling point varies with the concentration, right? So mixtures do not have fixed melting and boiling point. Most of matter around us exists as mixture of two or more pure substances. Say air is a mixture, milk is a mixture, blood is a mixture, right? So there's a mixture is what? It is an example, or it is an impure substance. So these are the characteristics of impure substances. Now let's discuss mixtures in details. How many types of mixtures are there? There are homogeneous mixtures, there are heterogeneous mixtures. What is the difference between the two? Types of mixtures. Now how are mixtures formed? Mixtures are formed by the combination of two or more substances. That is, two or more pure substances, the elements or compounds, which are not chemically combined with each other. Right? So, two or more pure substances combine, right? But they do not react, but they do not combine chemically. Right? And these can be separated by physical processes of separation or physical methods of separation. Now mixtures are of two types, homogeneous mixtures and heterogeneous mixtures. Let's take up homogeneous mixtures first. Homogeneous mixtures. A mixture is said to be homogeneous. A mixture is said to be homogeneous if the different constituents or substances present in it are uniformly mixed and are indistinguishable from one another. The composition is uniform and every part of the solution has same properties. That is the mixing of the two substances. Say a mixture is formed by combination of two or more pure substances. These substances do not react with each other. Now a mixture in which there is a uniform mixing of the components. Say for example the sugar solution is given over here. There are two components, sugar and water. Now the uniform mixing of the sugar and water leads to the formation of a homogeneous mixture. In a sugar solution, can you see sugar? Can you just identify a boundary between sugar and water? No, that is uniformly mixed. And sugar and water in sugar solution are indistinguishable. Indistinguishable means you can't just from a sugar solution you can't point out that this is a sugar and this is water. You can't separate sugar and water from sugar solution. Of course you need to do evaporation or other process for separating sugar and water, but you can't identify a boundary between sugar and water. See, sugar is being poured into the glass of water, this will get dissolved. Once this is a sugar solution, here I can't say that this is sugar, this is water, this is sugar, this is water. No, there's a uniform mixing of sugar and water. And secondly, the composition is uniform. That is, it's not that at one part of the sugar solution of the glass the concentration is very high, that is, the large amount of sugar is present. In the other part, less amount of sugar is present. In one part, large amount of sugar is present. It is not possible. The composition is uniform. That is, throughout the sugar solution, the concentration of sugar will be the same. Right? The composition will be the same. And the solution has got the similar properties. Say if I'm boiling a sugar solution. So it will boil at a particular temperature. It is not fixed. Of course, the boiling point of the solution or a mixture depends upon the concentration. But once I have prepared a solution and I am boiling it, it doesn't happen like one part of the solution is being boiling and the other part is cool. The whole solution shows the similar properties. Whatever property is there, right? The density will be similar, will be, say, it will be the same throughout the solution. That is, the composition is uniform and every part of the solution has same properties. That is, every part of the solution will have the same density, same refractive index. Right? So what is a homogeneous mixture? In a homogeneous mixture, the components are uniformly mixed, first of all. It is difficult to identify the components. We can't set up a boundary between the two components. The composition is uniform throughout the solution and every part of the solution shows same properties. Right? So here is an example, one more example. Solution of sodium chloride in water or sugar in water. Different constituents are uniformly mixed throughout. It is not possible to identify them. Obviously, from a salt solution, you can't identify salt grains unless or until it is precipitated. That is, it is settled at the bottom. So the components, they mix up uniformly. It is difficult to identify each and every component. Right? The composition is uniform throughout and every part of the solution has got same properties. Right? I hope you have understood this. Say, we can't say that I'm taking in this bowl the salt solution. I can't say that this particular part of salt solution will have different property. This part of salt solution will have different property. No. This complete solution will have same property. Right? That is, I can't say that this particular part of the solution will boil at 90 degrees centigrade. This particular part of solution will boil at 120 degrees centigrade. No. I can't say that this particular part has got the density some 2 gram per cubic centimeter. This part has got some 0.11 gram per cubic centimeter. No. It will have the same property throughout the solution. The composition is uniform. That is, the concentration of salt in every part of solution is uniform. This is what is homogeneous mixture. Say air is also a homogeneous mixture of number of gases like nitrogen, oxygen, carbon dioxide, water vapor, inert gases, etc. See, from air you can't point out this is carbon dioxide, this is oxygen, this is water vapor. No, they are uniformly mixed. All the gases present in air are uniformly mixed throughout. It is not possible to identify gases present in the air. Say, I can also mix copper sulfate solution in water. Copper sulfate is what? It is a blue colored compound. It is also called as blue vitriol. Now when it is mixed in water, a blue colored solution is obtained. Now this intensity of blue color throughout the solution is same. It's not that at this part you are finding a dark blue color, at this part you are finding a light blue color, here you are getting some different shade of blue. No. The intensity of blue color will be uniform throughout the solution. Right? So these are the homogeneous mixtures and the properties of the homogeneous mixtures. So what happens in a homogeneous mixture, or how homogeneous mixtures are formed? How homogeneous mixtures are formed? The components or the constituents, they combine uniformly. Right? They are mixed uniformly. Their composition is similar throughout the solution. They show similar properties. That is, every part of the solution will show same property. right? We can't identify the components or constituents in a homogeneous solution. We can't set up a clear boundary between the constituents of the solution. I hope you have understood this. Now I'll take up the heterogeneous solution. Heterogeneous mixtures. See how these are. Isn't it, can't you set a boundary between different components? See, this is different, this is different, this is different, this is different. Now the different constituents or the components can be identified in this, and a specific boundary can be set between them, right? And the properties also, they'll be different in different parts of the mixture. Okay, so the part where the lighter substances are present, the density of that part will be less. Where the heavier ones are present, the density of that part will be more. So in case of heterogeneous mixtures, the components are not uniformly mixed. The components or the constituents can be identified. A boundary can be set between them. So this is what this picture is depicting a heterogeneous mixture, right? Mixtures of, say, rocks, pebbles, stones, and many other things are there. A mixture is said to be heterogeneous if it does not have uniform composition. See this? You can see the picture over here. That is, it is not having a uniform composition over here, right? Then, and also has visible boundaries of separation between the constituents. See this? This mixture, heterogeneous mixture, doesn't have the uniform composition, and it is also having a boundary between the constituents. In these type of mixtures, substance remains separate and one substance is separated throughout the other substance as small particles, droplets or bubbles. So these substances are separated in the heterogeneous mixture. Substance is what? It is a pure form. It is a pure form which cannot be separated into the other forms of matter. It is a pure form of matter. So one substance is separated throughout the other substance. Say this, the soup. It is also a heterogeneous mixture. It is a mixture of this pasta, this water is over there, and some carrots, something like that is there. So the substances, this pasta or carrots, these are just spread in water. This is not a uniform mixture. This particular soup is not having a uniform composition, is not having a uniform composition. We can set boundaries between the constituents. Likewise, the salad bowl, it is also a mixture. Here also the salad bowl is not having a uniform composition. The properties are different in different parts of the mixture, just like here. It is not having uniform composition. The boundaries can be set between the two constituents or components present in the heterogeneous mixture. So is it clear? The homogeneous mixture and heterogeneous mixture. This is another example of heterogeneous mixture. See this, flour plus water. Flour particles can be seen in water. They are suspended. This is a suspension. It is not a clear solution. So if I am adding salt in water, I'll get a solution of salt and water where I can't see the salt separately in water. It will be uniformly mixed. I can't identify this is the particle of salt, this is the particle of water. No. But in this case, say flour and water, we can see the flour particles suspended in the liquid. Suspended means it is not dissolved in the liquid. It is not precipitated. Precipitated means it is not settled at the bottom. So all the suspensions and colloids are heterogeneous mixtures. Suspensions are what? Heterogeneous mixtures. Right? A mixture of sugar and sand is also heterogeneous. So if I am mixing sugar and sand, I can identify sugar particles from the mixture, and as well as I can identify sand particles in the mixture. And I can set a definite boundary between the sugar and sand particles. Also, the mixture will not have uniform composition. Also, the mixture will not have same properties throughout the mixture. Right? So, all of these are heterogeneous mixtures. Now, let's discuss few properties of mixtures. See, properties of a mixture. The constituents of a mixture can be separated by physical methods of separation. I have told you. Say if I am mixing sugar and sand, I can separate sand from sugar by using a sieve. Right? Say a mixture of flour, wheat flour and water. I can separate the particles of wheat flour from water by using a sieve. Okay. Say a mixture of salt and water. I can separate salt from water by evaporation. So likewise, the constituents of a mixture can be separated by physical methods of separation. Whereas the constituents of a compound like ferrous sulfide or hydrochloric acid or water, they cannot be separated by physical methods of separation. The elements, the particles constituting an element, any element I can take, that is, say if I am taking sodium or chlorine, the particles of these elements cannot be separated by physical method of separation as well as chemical method of separation. Right? So these are what? These are pure substances. Whereas the constituents of mixture can be separated by physical methods of separation. Say for example, iron filings and sulphur powder. They are mixed together. Right? A grayish yellow mixture is obtained. See this is mixed. This is grayish yellow mixture is obtained. This is sulphur powder. These are iron filings. These are mixed together, and the substance obtained is a mixture of iron and sulphur. A grayish yellow mixture is obtained. From this, iron can be separated. How? By using a magnet. So if a magnet is used, iron particles will stick to it and they will be separated. But if this iron particles, say iron filings, are heated with sulphur powder, it will form ferrous sulfide. Now this ferrous sulfide is a compound, and from this ferrous sulfide, iron particles cannot be separated. By magnet. Because see, a compound shows properties altogether different from its constituents. Whereas a mixture shows properties of its constituents. Do you remember? So the constituents of a mixture can be separated by physical methods of separation. So for separating iron and sulphur, one more thing can be done. By dissolving mixture of iron and sulphur powder in an organic liquid known as carbon disulphide. Now this carbon disulphide dissolves sulphur. Say this is carbon disulphide solution. To this, if the mixture of iron and sulphur is added, what will happen? Sulphur will get dissolved. But iron doesn't dissolve. So on filtration of this solution or on filtering this solution, iron is obtained as a residue. And how can we recover sulphur? By evaporating carbon disulphide. So this is also one of the method by which the iron and sulfur can be separated from mixture of iron and sulfur powder. One is by magnetic separation, another is by dissolving it in carbon disulphide, which dissolves sulfur but doesn't dissolve iron. Right? When the solution is filtered, iron will be separated and sulfur can be separated from carbon disulphide by evaporating. What? Evaporating carbon disulphide. Let's take few more properties of mixtures. A mixture shows the properties of all the constituents present in it. Say if dilute sulphuric acid is added to the mixture of iron filings and sulfur, iron reacts with sulphuric acid and hydrogen gas is produced, whereas sulfur remains unchanged. What is being done is, say I am taking this mixture of iron and sulfur. This yellowish brown colored mixture. To this, what is added is sulphuric acid. Right? Now, with this sulphuric acid, iron reacts, forming FeSO4 iron sulfate and hydrogen gas is evolved. There is no need for you to remember this reaction. Just remember that iron reacts with sulphuric acid and sulfur, it doesn't react with sulphuric acid. Right? This shows that a mixture of iron and sulfur shows the properties of iron. Now, if this mixture of iron and sulfur is treated with carbon disulphide, what dissolves in it? Sulfur. We have just now did it. So, it shows the properties of sulfur also. So, a mixture shows the properties of all the constituents present in it. Had it been iron sulfide, not the mixture of iron and sulfur. Had it been iron sulfide, it would not have reacted. It would have given some different product, or it would not have reacted with H2SO4 or carbon disulphide, because it is a compound. And it will show different properties from iron and sulfur. Different properties from its constituents. Right? There are a few more properties. The formation of a mixture is a physical process. Chemical reaction does not take place between the constituents. We are mixing salt and sugar. No reaction is there. We are mixing sugar and water. No reaction is there. So, formation of a mixture is a physical process and no reaction takes place between the constituents. Right? Now, when no chemical reaction is taking place, heat will neither be given out nor absorbed in the process. In the chemical reactions, what happens? Say H2O. Hydrogen reacts with oxygen, giving water. Now in this, what is happening? There is bond between hydrogen atoms, there is bond between oxygen atoms, and there is bond between hydrogen, oxygen and hydrogen. What is bond? Bond is the force of attraction between the two atoms. So what is happening in the formation of water? The bond between hydrogen and hydrogen is broken. The bond between hydrogen, oxygen and oxygen is broken. Now to break this force of attraction, see, the two atoms are attracted strongly. To break this force of attraction, what is required from outside? Heat energy. Or high temperature is required, or energy is required. Right? And in the formation of the bond, attraction, there is attraction between these two atoms, that is oxygen and hydrogen. There's a force of attraction between them. Due to this force of attraction, what happens? Energy is released. So it depends on net that if the energy released is more than energy absorbed, then the energy is released, right? The energy may be released or may be absorbed in a chemical process. But in this case, say in the formation of a mixture, sugar plus sand. In the formation of a mixture, iron filings plus sulphur, there is neither the energy is required nor the energy is released, because it's a physical process. It's just the outside mixing. There is no reaction taking place, right? So heat is usually neither given out or nor absorbed in the process. The composition of a mixture is variable, that is, the constituents can be present in any proportion by mass. Say in a compound H2O, hydrogen and oxygen are present in the ratio of 1:8 by mass. In carbon dioxide, carbon and oxygen are present in the ratio of 3:8 by mass. But in a mixture, there is no ratio as such. The composition is variable, right? A mixture does not have definite melting point and boiling point. Remember this, a mixture is not having a definite melting or boiling point. These melting or boiling point depend upon the concentration of the solute or the substance present in the solution. They depend upon the concentrations, they depend upon the nature of substance. But a compound has got a definite melting and boiling point. So these are the properties of mixtures and the types of mixtures, right? I have enjoyed discussing this topic. I hope you have also enjoyed listening to it. Now I'll be concluding this session, students. In the next session, we'll be discussing about the solutions, right? Thank you, students, for being with me, and just go through your text so that these basic concepts of pure substance, impure substance, elements, compounds, mixtures, homogeneous mixture, heterogeneous mixture is clear in your mind. This is a very, very basic chemistry. So you should know about it. So thank you once again, and do have a nice time ahead.